Hello, this is Mr. Rimon, IGCSE math teacher for Edexcel and Cambridge O and A levels. Today we are gonna talk about surds. Simply, when we can't simplify any square root or any cube root or any other root, then it's a surd. For example, if we have root of 2, this is called surd. Why? Because 2 is not perfect square number, so we cannot find any number to multiply by itself and give me 2. So root of 2 is a surd. For example, root of 3, it's also surd because 3 is not perfect square number. Cube root of 5, this is a surd. Why? Because 5 is not perfect cube number. I cannot find, or I don't have any number to multiply by itself 3 times and give me 5. Square root of 4, this is not a surd. Why? Because 4 is a perfect square number. Because square root of 4 equal positive or negative 2. And we put positive or negative because positive 2 times positive 2 equals 4, and negative 2 multiplied by negative 2 still equal positive 4. More example, cube root of 8, also not a surd. Why? Because 8 is a perfect cube number. Because cube root of 8 will give me 2. And in any cube root, if we have positive number inside, so the answer will be positive. If we have negative number inside, the answer will be negative. Okay. Example, find the value of each root. Number 1, root of 100, it's so easy to find the number which multiply by itself and give me 100. So you can do it by your calculator. This is 10, and don't forget positive or negative. Okay, cube root of 512. What is the number I will multiply by itself 3 times and give me 512? You can do it by your calculator. It's 8. And we have positive 512, so we have positive 8. So positive 8 times positive 8 times positive 8 equals 512. Number 3, square root of 50. Okay. Here 50 is not perfect square number, so we cannot find the square root of 50. So how can I simplify this root or this surd? First step, we will find the factors of 50. So we already have 1 times 50, and we have 2 times 25, and we have 5 times 10. Okay, here only we will select the perfect square number. We have here a number other than 1, so we have 25. So instead of root of 50, I'm gonna write root of 25 multiplied by 2. Then we will find the square root for each number. So root of 25 equals 5, and root of 2 we don't have, so we keep it here. So 5 root of 2 is the answer of root of 50. Okay. Number 4, cube root of 81. Okay, do we have cube root for 81? Do I have a number which I multiply by itself 3 times and give me 81? No. If you do it with calculator, you will get a rational number. So how can I solve it, or how can I simplify this surd? I will find the factors of 81, and I will look for a perfect cube number from the factors of 81. So we already have 1 times 81, we have 3 times 27, and we have 9 multiplied by 9. Which number here other than 1 is a perfect cube? We have 27. So cube root of 81, instead of 81, I'm gonna write cube root of 27 multiplied by 3. And we will find the cube root for each number. So cube root of 27, what is the number I will multiply by itself 3 times and give me 27? So it's 3. Cube root of 3, we keep it here. So the final answer is 3 cube root of 3. Okay. Here, operation on surds, addition, subtraction, multiplication, and division. Number 1, for example, we have 2 root of 5 plus 4 root of 5. Can I add? Yes, because we have the same order of root and the same number inside the root. So here I have, in the first term, I have a square root of 5, and in second term, I have a square root of 5. So we can add. Okay, which numbers I will add? I will add only the numbers in front of the root. So we add only 2 and 4. So 2 plus 4 equals 6, and we keep the same root. So the answer is 6 root of 5. For number 2, I have the same root, so we can subtract, and we will subtract the numbers in front of root. Here I have 8, but in second term we don't have a number in front of root of 3, and that means that we have 1. So 8 minus 1 equals 7 root of 3. Number 3, for multiplication, just multiply the numbers inside the root. But if you have the same order of root, so here I have a square root and also here I have a square root. So root of 3 times root of 5 equals square root 3 times 5 equals 15. Okay, can we simplify more? No, because 15 is not perfect square number and there is no perfect square factor for 15. Okay, one more for multiplication. Root of 6 times root of 6. This will be root 6 times 6 equals 36, and root of 36 equals 6 also. So quickly after that, if you have the same number inside the root, just remove the root. More example, if we have root of 3 multiplied by root of 3, so directly I'm gonna write 3. Number 5, for division, we have root of 8 divided by root of 2. So just divide the numbers inside the root because we have the same order of root. We have square root. So we have 1 square root. 8 divided by 2 equals 4, and root of 4 equals 2. Okay. Here we have different example. Simplify or rationalize the denominator. What's the meaning of rationalizing denominator? Rationalize means that you have to get rid of the root from denominator. What if I have a root in numerator? It's okay. My problem with the root in denominator. So always, and generally in math, if you have a square or any kind of root, any order of root in denominator, you have to remove this root. Okay, can I remove this root? By multiplying by the conjugate of denominator, or by multiplying by the same root here for both numerator and denominator. Okay, why? Because root of 5 times root of 5, just we will get rid of the root as we did in operations, multiplication of roots. Okay, so I will multiply numerators together and denominators together. In denominator, root of 5 times root of 5, just 5. In numerator, 3 times root of 5, it's 3 root of 5. So the answer, we can write it as 3 over 5 root of 5. So we have root okay in the final answer, but it's not in the denominator. So this is the simplest form. Okay. Now let's solve some questions from past papers. This question number 19 in November 2004 and 3H. Okay, express root of 98 in the form a root of b, where a and b are integers and a more than 1. Okay, we have root of 98. I have to ask myself, is 98 is a perfect square number? No, there is no any number to multiply by itself and give me 98. So what will I do? I will find the factors of 98. So already we have 1 times 98, we have 2 times 49, we don't have 3, and we don't have 4 nor 5, we have 7 multiplied by 14. Okay, which number from these factors of 98 is a perfect square number? Other than 1, it's 49. So instead of root of 98, I'm gonna write root 49 multiplied by 2. And I'm gonna find the square root for each number. So root of 49 equals 7. And root of 2, we keep it here. So 7 root of 2 is the final answer. So we found it in the same required form. Okay. Another question. Question number 20, January 18. Root of 50 plus root of 128 minus root of 200 equal n root of 2, where n is an integer. Find the value of n. Okay. For the first term, 50 is not perfect square number, so it's a third. 128 not perfect square number, third. 200 not perfect square number, third. Okay, so we have to find the factor for each numbers. So for 50, for example, we have 1 times 50, we have 2 times 25, we have 5 times 10. So we will select 2 times 25, and we are going to write it here. Instead of 50, 25 multiplied by 2. Plus, now root of 128, so we will find factors of 128. So we have 1 times 128, we have 2 times 64, we have 4 times 32, and we have 8 multiplied by 16. Okay, here we have many perfect square numbers. We have, other than 1, we have 64, we have 4, and we have 16. So which perfect square number I will take here? We will take 2 times 64. Always select the highest perfect square number. So here, instead of root of 128, I'm going to write 64 multiplied by 2. Minus, now root of 200. So 200, we have factors already. 1 times 200, we have 2 times 100, we have 4 times 50, 5 times 40, and we have 8 times 25, and 10 times 20. Okay, we have many perfect square numbers, but we will take the highest one, which is 100. So instead of 200, it's 100 multiplied by 2. Okay, let's simplify each term. The first one, root of 25 is 5, and we keep here root of 2. Plus root of 64 is 8 root of 2. Minus root of 100 is 10 root of 2. So equals, we have the same square root of 2 in all terms, so only we add or subtract the numbers in front of roots. So 5 plus 8 is 13, minus 10 equal 3 root of 2. And comparing to the right side, my question, so equal n root of 2. If you cancel out root of 2 is root of 2, so we have n equals 3. So the final answer for n equals 3. Next question. Show that 12 over root of 8 equals 3 root of 2. Okay, my expression 12 over root of 8. Okay, I need to simplify or rationalize the denominator. How? By multiplying by root of 8 for both numerator and denominator. So in denominator, root of 8 times root of 8 directly equal 8. Numerator, 12 times root of 8 is 12 root of 8. Okay, we need to simplify more because we didn't get to the required answer. We need to find 3 root of 2. Okay, here we need to find the value of root of 8. 8 is not perfect square number, and we need to simplify more, so it's equal 12 root 8. Instead of 8, I will write 4 times 2 over 8. So equals 12. Here, let's put this in brackets. Root of 4 is 2 root of 2 over 8. Now we will multiply 12 times 2 equal 24, then root of 2 over 8. And here we can simplify more because 24 is divisible by 8. So divide by 8 equal 1, divide by 8 equal 3, 3 over 1 equal 3 root of 2, and this is the required one. Okay, next question. Given that a is a prime number, simplify 5 root of a plus a over 10 root of a. Give your answer in the form x plus y root of a, where x and y are fractions. Okay, so we have 5 root of a plus a all over 10 root of a. How can I get rid of the root from denominator? By multiplying both numerator and denominator by root of a. So in denominator it's so easy, 10, and root of a times root of a is a. In numerators, here we will put the first numerator in brackets. We have two terms, so we are going to use distributive property. Multiply by the first term and multiply by the second term. So root of a times 5 root of a will give me 5a, plus root of a times a will be a root of a. Okay, we need to simplify more. We have common factor in numerator, which is a. So I will take a as a common factor, and in brackets I'm going to write 5 plus root of a all over 10a. Now we can cancel a with a, so equals 5 plus root of a over 10. After that we can divide each term in numerator by 10. So 5 over 10 plus root of a over 10. And we can simplify more. So here divide by 5 equal 1, divide by 5 equal 2. So we have 1 over 2 plus, here we have 1 in front of this root, so 1 over 10 root of a. So we found the same required form in question, and already x and y are fractions. X equal 1 over 2 and y equal 1 over 10. Next question. We have two brackets multiplied together, so we will expand, or we will multiply, and using distributive property. So first term by first term by second term by first term, second by second. And after that we will compare with the right side to find the value of e and f, which are positive integers. Okay, so first term by first term, 5 root of 2 times 3 root of 2, step by step. The numbers outside the root, 5 times 3 is 15. Root of 2 times root of 2 is 2. Then 5 root of 2 times e, positive times positive, positive. So it will be 5e root of 2. Then second term with the first, so negative times positive, negative. E times 3 root of 2, it will be 3e root of 2. Then negative e times positive e, this will give me negative e squared. Let's simplify more. 15 times 2 equals 30. We have here like terms, so 5e root of 2 minus 3e root of 2, 5 minus 3 is positive 2e root of 2 minus e squared. Okay, comparing to the right side now, equal f root of 2 minus 6. Okay, when we compare, we have to put 2e root of 2 equals f root of 2, because here I have the same order and the same root. Okay, and also we have 30 minus e squared will be equal to negative 6. Okay, which terms I'm going to use firstly? I will use 30 minus e squared equal negative 6. Why didn't I use 2e root of 2 equal f root of 2? Because here we have two unknowns, so it will be difficult to solve this one. But here 30 minus e squared equal negative 6, we have only one unknown, which is e, so it's a normal quadratic equation. Okay, so normally here minus 30 minus 30, So we cancel, so we have negative e squared equal negative 36. Then we can cancel negative with negative. Let's continue here. So e squared equal positive 36. Then we will find square root for each side. So e equal 6. And I will not write positive or negative because he mentioned in the question that e and f are positive integers. Okay, after finding the value of e, we have to find the value of f. So 2e root of 2 equal f root of 2. So we can cancel root of 2 with root of 2. So 2, and we can substitute now for e. So we will put 6 instead of e equal f. So 2 times 6 equal 12. So the final answer for e equal 6 and f equal 12. Okay, next question. Given that a is a positive integer, show that root of 3a multiplied by the expression root of 12a plus a root of 3a is always a multiple of 3. Okay, here we have one term by two terms or expression in brackets, so already we have expanding, we have to multiply and using distributive property. Even if I don't understand how to show multiple of 3, just all what I have to do that I multiply. After that we can see how to show that it's a multiple of 3. Okay, root of 3a times root of 12a step by step equal square root 3 times 12 equals 36. A times a is a squared plus root of 3a times a root of 3a. Here we have 1 outside, so 1 times a is a, and root 3a times 3a is 9a squared. Now simplify. Root of 36 equals 6. Root of a squared is a plus a brackets root of 9 is 3. Root of a squared is a. So equals 6a plus a times 3a is 3a squared. Okay. Now we are done with multiplication. How can I show that it's a multiple of 3? Multiple of 3 means any number multiplied by 3, or any expression, any term multiplied by 3. So just here you can take 3 as a common factor, or take the highest common factor for this expression. For example, I can take 3a, and in brackets now we will divide each term by 3a, so 6a divided by 3a equal 2, plus 3a squared divided by 3a is a. So we have all this expression multiplied by 3, so now it's a multiple of 3 already. Okay, last question today. Expand 5 plus 3 root of 2 squared. Squared here power 2, it means that we will repeat the brackets 2 times. So we can use distributive property always here. First by first, first by second, second by first, second by second. It's a longer way, but it's easier. So 5 times 5 is 25, plus 5 times 3 root of 2 is 15 root of 2, plus 3 root of 2 times 5 is 15 root of 2 again, plus 3 root of 2 times 3 root of 2, 3 times 3 is 9, root of 2 times root of 2 is 2. So we have 25. The second and the third term are like terms. So plus 15 is 30 root of 2, plus 9 times 2 is 18. Do we have more like terms? Yes, we have the first one and the last one. 25 plus 18 equals 43 plus 30 root of 2, and this is the same required form. He didn't ask me about the value of a and b, so the final answer only here 43 plus 30 root of 2. This was the last question. This was Mr. Ramon. Thank you so much.